How could you measure the size of the Earth using a shadow and a camel? 2,000 years ago, a scientist called Eratosthenes lived in Egypt. One day, he read a note about a town called Syene. The note said that on the summer solstice at 12 o'clock, when the sun was directly overhead, buildings in Syene didn't cast a shadow, and sunlight could be seen at the bottom of the deepest wells. Eratosthenes thought this was interesting, so he decided to investigate. Imagine that I'm the center of the Earth, and, well, this is it right here, and the sun is all the way out there. Here is the town of Syene on the equator of the Earth, and here is a building in Syene. On the 21st of June at 12 o'clock, a building in Syene points directly at the sun. A sun ray coming in, signified by my yellow wooden rod, hits the top of the building and doesn't cast a shadow. Okay, interesting. But Eratosthenes wondered if this was the same in Alexandria, where he lived. Eratosthenes went outside and placed a stick in the ground and waited for the sun on the 21st of June at 12 o'clock. Well, the stick did cast a shadow. He made his first realization. The surface of the Earth must be round. Alexandria is a couple of 100 kilometers north, so a building in Alexandria points at an angle. A sun ray comes in, hits the top of the building, and does cast a shadow. Okay. And if the Earth was flat, a building in Alexandria would point directly at the sun and cast no shadow. Must have been a pretty major realization for 2,000 years ago. Now, the next thing, he realized he could take it further. He knew that if two parallel lines had a line connecting them, opposite angles would be the same. So the angle between a tower in Alexandria and a sun ray was the same as the angle between Alexandria and Syene. So he measured this angle, and you can see it's the shape of a Z, so the angles are going to be the same. So he found this angle by measuring the length of the shadow in Alexandria, and he found it to be 7 degrees. Okay, well, 7 degrees is about a 50th of a way around a circle with 360 degrees. If he can find the distance from Alexandria to Syene, he can find the circumference of the Earth. So what does he do? He pays a man to take a camel from Alexandria to Syene, takes him 2 weeks. That man comes back and tells Eratosthenes, it's 800 kilometers. Eratosthenes takes 800 kilometers and multiplies it by 50 to find the full circumference of the Earth. What does he get? 40,000 kilometers. If you Google the circumference of the Earth today, it says 40,075. Eratosthenes' estimate was remarkably close. That's how you measure the size of the Earth, using shadows and a camel.